Hey class, let's talk about output formatting in C++. We've dealt a little bit with this already. We've tried to use the tab character to line up our output and to make our formatting look semi-decent. We've also encountered the fixed count manipulator and the set precision count manipulator so far. I wanted to kind of review what those actually do in the context of output formatting. And then we're going to add one more today, and that is set width, SETW. Now, to review these, there are specific combinations that do specific things. So if you were to just do count fixed like this, then all that does in and of itself is it forces the decimal place to be displayed. Or in other words, it forces fixed notation. That's as opposed to scientific notation. If there's a very large number, C++ will default to using scientific notation for that. But you can force it to do the regular numeric notation with a decimal place using fixed. And then accordingly, there's also a corollary count manipulator, also called scientific, that we can also use. So with that said, set precision in and of itself, if we were to do count and then set precision and give it, say, a number of 8, all set precision does by itself is set the number of digits that you'll see in an answer. So if your number, let me scroll up a little bit here. If your number is, let's say 162.3489, and if you do a set precision of, say, 6, then when you output val, you will get 6 digits total, including before and after the decimal place. So you will get this one, this one, this one, 1, 2, 3, and then 4, 5, 6, and then the rest of this precision is just lost, and we will get just those 6 digits. If you're doing a set precision of, say, 4, and your number is 132.65, you'll just get 132.6. 1, 2, 3, 4 digits. Now, when we used fixed and set precision together, those control the number of decimal places. So they can appear in any order, so either fixed set precision or set precision and fixed, and make sure that you provide an argument to set precision. It does take an integer. So let's look at some code now to experiment with this stuff a little bit. Okay, let's start here. So if there are large numbers or large numbers of digits, C++ will generally default to scientific notation. So here's just a very large double, a literal that I've typed in. If I were to count this, we get scientific notation there in the run. And remember, with C++, by default, you get a precision of 6 places. So remember, that's 6 places, including before and after the decimal place. So you see we get 1.42343. That's our 6 digits of precision. And then the rest of the scientific notation there saying move the decimal 7 places to the right. Now, sometimes we may not like the defaulting to scientific notation, and that is fine. We can use the fixed manipulator like this, and that forces fixed notation throughout your program until it's changed back to scientific. So if we were to run this again, then we would get a similar or much better response here. We see that we get just about the full double output. And again, if you have a large number like this with more than 6 significant digits, you are going to get all of them. And C++ will default to giving you 6 decimal places by default. So you see here that some of the decimal places are lopped off. So you get 6. All right, so that is what fixed is going to do. It will force fixed notation. The next thing let's take a look at is set precision. And remember that set precision controls the total number of digits, albeit before or after the decimal point. So here I'm going to set a precision of 6 and just output that number. There are our 6 digits that we get. And the rest then is rounded. Let's try a 7. And we get that 7th digit. Let's try an 8. And you guessed it, we'll get that. And there's our 8 significant digits. And rounding does occur here. So that's set precision and just what that does by itself. Now, when we put these together like this, fixed and set precision together, it's only this combination here that will control the number of decimal places. So don't forget that in your coding. This can happen in either order, but with our code here, we should expect to get exactly 2 decimal places, and sure enough, we do. And let's presume that the number supports it, then there will be some rounding to occur to get those necessary digits. So that is our fixed set precision and fixed set precision review. Now let's take a good jump into set width. Okay, what set width does for us is it allows us to define the width of an output field. Now, we've seen when numbers are neatly aligned in a column that they sort of form a field or a specific column with a specific width. When we see maybe some labels assigned to describe what the rows might be, those might be in their own column. So there's a field width involved there. So let's take a look at just a super quick example that I'll draw out here, and then how we can figure out, well, what are the fields or columns here and what widths should we do? Suppose we want this output. We've got some data. We've got numbers stored in variables that will just be output here. And we want, though, to have formatted output. Notice right away that with this output, we see that there's some alignment. We see that all of these labels here, food, tax, etc., are all right justified, and they're aligned according to this blue line here. Same thing with our numbers. You can see that they are all aligned to the right. They all line up here. And note also here how all of the decimal points line up. And so this is also right justified. If it was left justified, these would all be over on the other side. They're just going to be pushed over that way, sort of like this. Food. Our normal writing style is left justified. Subtotal, so you kind of get this shape. So these right away tell us what are our fields, what are our columns. It's going to be column 1 here for the label for whatever that row is, and then a column 2 here for the data, for the number. So given our choices here that we're making, let's figure out how we would code this to support that we are doing 2 columns, 2 fields. Our first choice is how wide will we make these columns? So you have to estimate here, and if you don't like how it turned out, you can easily just change it. The beauty is we're going to program these field widths in constants, so changing them is going to be quite easy. We're going to change just one number rather than hunting through our code and trying to correct just the correct set width manipulators. So, make sure that the longest or largest string that could possibly be output in that field could fit reasonably in that field. So here subtotal is 8 characters plus this colon, and I'll add a few more. So I'll make it 15. Similarly, for the numbers, we can see that while the longest one is 6 characters long, 132.68. So let's just add a few extras in there. Let's call it 11 and see if we like it. Now, what we'll do with these numbers 15 and 11 is we will make them constants. Since this basically is field 1 or column 1, and this is field 2, let's make 2 constants, W1 and W2. Just like this 1 and W2. And these will represent the column widths that we're going to go for. So we'll do a 15 there and an 11. And this then will give us W1, W2 that we will use quite frequently in our set widths. Now, given that we've sketched out our layout and we've decided what the columns should be, and we've decided what the column width should be, well, then it's just a matter of coding in that set width manipulator. And it's just simply going to be in front of whatever variable. So if we were to count and wanted to do the first column's set width, that's how we would do that. And what happens is this set width applies only to the following element. So if it's a string, it's going to try and fit the string in that column width. If it's a number, it's going to do the same thing. Whatever you put in there, it's going to try and set in that column width. And then perhaps, we would, here we'd have the title or the string food. So we've got that one done. Let me erase this little line here. And then to output to the next column over, we just do the same procedure. We're continuing to output on that line. We haven't done a carriage return yet, so we'll just do another set width. This time we will use the constant that we decided for that second column or second field. And then here, why don't we just put our variable? And then let's also do an end line. So that is precisely how set width is going to work. And again, the beauty is if you don't like how it's spaced out, then just go up and change the constants, and it makes really rapid prototyping and rapid experimentation a breeze. So here's how we'll line these up. I've got a double variable for food and another one for tax. And let's try and get these outputs so that they're aligned. So we'll just start with our count. We're first going to do food as a string, just like that. There we go. Let's output this, and it's going to be a mess. We don't have any alignment at all. Now, we had mentioned that we wanted to do 15 for the first field. So let's go ahead and create that constant. And then we had said that the second field is going to be 11. So coding those in, that sets us up to be able to use set width with those constants. So let's try the very first thing. Let's just do a set width here. And see what happens. Just that one, that statement. And we can see that, well, food was output way over. It's like it tabbed, it went way, 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 way over. So to figure this out, well, we can actually almost count the number of spaces. And if we were to count those, we'd see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It did exactly what we told it to do. It said, we instructed it to output this string in a field width of 15, and that's what it did. Let's do that second one. There's another entity there to be output, and that is the variable food. And it's common to break up your count statements so that you've got kind of one kind of pair of count manipulators and elements per line, so that you can visualize kind of better what the columns are. So let's do another set width here with W2 and see what happens there. All right, well, that's actually looking pretty good. The food amount is now all the way over here to the right, which is where we wanted it. So since that looks good, let's just repeat that for the tax. And since I want us to be lazy programmers, then I do want us to copy and paste as much as we can, and then just correct the differences. So now then here will be tax. Let's see how that turns out. And look at that, everything's starting to align up. Now, you've got to use constants for these. Otherwise, if you had an entire page using this W1, W2, and you wanted to make one change, well, then you've got 50 or 100 changes to make. And we don't do that in computer science. We're not heathens. We will use constants. And if we decide, well, that is a little too broad, I want to make it a field width of 8, well, then we just made one change, and now that field width has just shrunk there for the first column. Same thing for the second one. Maybe 11's too big. Why don't I do, how about 7 for that? And there we go. So I hope this helps put together a broader picture of output formatting, and just having this one additional count manipulator with set width can really expand our capabilities to have some decently formatted output, especially neatly aligned columns that we would expect to see in any professional application. Now, let's take a look at one more thing, and that is, well, how do we, I'll do that one in a later video. So I think that should be good for now. Pop your questions up there in the discussion board, please, and we'll see y'all online.